Hello everybody, today we are going to talk about the volume and surface areas of our final shape, which are spheres. The volume of a sphere is equal to 4/3 times pi times the radius cubed. So this formula, the only variable that you have to know is r, which is your radius right here of your sphere. A couple things that I want you to make note of. R to the third power on your calculator, what you can do is you have this little caret button that you can find and you're raising it to the third power. The other thing that you can do is if you have r to the third, it's like multiplying r 3 times. So r times r times r. The other thing I want you to make note of is when you're using 4/3, when you're going to plug that into your calculator, I highly suggest that what you do is you multiply by 4 first, hit enter, and then divide by 3. It's just going to help your answer be more accurate and get the same numbers as me. I highly encourage, as you're going through this note sheet, make sure that you are following along with your calculator, pause the video as needed, double check that you can do the same calculations on your calculator so that you know how to find these measurements and numbers. The first example, they want to find the volume of a sphere with a diameter of 6. If I have a diameter of 6, then half of that means my radius is 3. So if I'm plugging it into my volume formula, I have 4/3 pi times my radius cubed. I take 3 to the third power on my calculator, multiply by 4, multiply by pi, divide by 3, and you should end up with a volume of 113.1 centimeters cubed. So double check on your calculator that you're getting the same thing. So first do 3 to the third power, then times pi, then times 4, then divided by 3. You get 113.1 centimeters cubed. For this one, it says find the radius of a sphere with a volume of 288 pi. So now you are given the volume and you want to find r. I still use the same formula, but now I know v. So I can plug in 288 pi in for v, and I'm solving for r. The first thing I'm going to do is I'm going to divide both sides by pi because they're both being multiplied by pi on both sides. I can divide pi and it's going to just cancel on both sides, leaving me 288 is equal to 4/3 r to the third. Then what I want to do is I want to multiply both sides by 3 to get rid of the 3 in the denominator on the right. So I'm going to multiply 288 by 3 and I get 864 is equal to 4r to the third. Then I want to divide by 4 to both sides, and that's going to leave me 216 r to the third. Now this is something that you haven't seen before. You have 216 equals r to the third. We learned how to take the square root on our calculator a couple months ago, but with this, there's a couple ways you can think about it. First, you're essentially asking yourself, what multiplied by itself 3 times gives me 216? Or on your calculator, you can plug in 216 raised to the 1 divided by 3 power, and you should get 6. So if I think about it, my radius is going to equal 6 centimeters because 6 to the third power equals 216. So we'll make sure to talk about that as it comes up again as well. But you get a radius of 6. We're going to define a couple terms here with volume and with spheres. We have to talk about hemispheres. So first, a great circle is the intersection of a sphere and a plane containing the center of the sphere. So essentially, it's what line around the sphere is going to cut it directly into two equal hemispheres. So it doesn't matter where it is, as long as you can see that it's going to cut the sphere directly in half. A great circle divides the sphere into what we call two hemispheres. So we have two hemispheres here. Here's one, and here's the other. Now, one thing that you'll have to do with hemispheres is find the volume. Well, a hemisphere is just half of a sphere, so when you're finding the volume of a hemisphere, all you have to do is first find the volume of the sphere. So 4/3 pi times, we have a radius of 3, so 3 to the third. We actually calculated this exact number up in problem 1. That equals 113.1 feet cubed. But then to find the volume of a hemisphere, all we have to do is divide that by 2 because it is half of that sphere. So 113.1 divided by 2, and I get a volume of 56.6 feet cubed. Now, we can apply this knowledge of volume to help us find the volume of composite figures. So in this case, you can see that I have a hemisphere on top of a cylinder. So all we have to do to find the volume of these values is just find the volume of the hemisphere, find the volume of the cylinder, and then add them together. So in this case, the volume of a hemisphere is 1/2 times the volume of a sphere with that radius. Well, I have a diameter of 2 down here, which means my radius is 1, and the radius of my hemisphere is also going to be 1. So I have 4/3 times pi times 1 cubed, and then that 1/2 in front is because it's a hemisphere and not a sphere. So when you calculate that out, I get the volume of my hemisphere is equal to 2.1 meters cubed. If you remember, back to when we talked about cylinders, the volume of a cylinder is the area of the base times the height. Well, in this case, my base is a circle, so that's pi times the radius of 1 squared, which is just pi, and then the height is equal to 3. So the volume of that cylinder is going to equal pi times 3, which is about 9.4 meters cubed. So now I want to find the volume of the entire figure, so all you're going to do is I'm just going to add the volume of the hemisphere plus the volume of the cylinder, and that's going to give me a volume of 11.5 meters cubed. If we look at this other example here, it's going to be a little bit different. So they tell me the height of a cylinder is equal to the diameter of the sphere. Well, if my radius is 12, that means that my diameter is going to be 24. Therefore, this height of the cylinder is going to be 24. They want to find the volume of the space between the sphere and the cylinder. So think of having a cylinder can, and you put a ball inside of it. This question is asking you to find the volume of the space that's left empty without the ball. So what we're going to do is first we're going to find the volume of the sphere. That's going to be 4/3 pi times 12, because that's my radius, to the third. And when I calculate that out, I'm going to get a volume of 7,238.2. So again, make sure that you're plugging this in your calculator so you know you're getting the same values. The next thing I'm going to do is find the volume of the cylinder. So again, that's area of base times the height. The area of the base is pi times the radius squared, which is equal to 144 pi. And then the height of the cylinder is 24, which we found at the beginning of the problem. So the volume of the cylinder is equal to 144 pi times 24, and I get 10,857.3 centimeters cubed, which is good because that cylinder is larger than my sphere, so I should have a larger volume. Now, to answer the question, they want to find the volume of that leftover space once I put the ball inside the cylinder. So the volume, I'm going to take the volume of that cylinder, and I'm going to subtract the volume of the sphere, and I get a remaining volume of 3,619.1 centimeters cubed. The final example that we are going to see revolves around surface area. So this is actually one of the easier formulas of what we are going to learn this chapter, and it's 4 pi r squared. So once again, you have your r as your radius. And if you remember, we did lateral area and surface area when we were doing our other shapes. In this case, the lateral area is equal to your surface area because we don't have bases. So in a sphere, you only have one face. So we don't have to distinguish between lateral area and surface area. They're the same. All you have to know is the radius, and you can solve for that surface area. So we're going to look at a couple examples. So find the surface area of a sphere with a diameter of 4. So now if I have a diameter of 4, that means my radius is 2. So if I plug it into my formula, surface area is equal to 4 pi times my radius squared. That would be 4 pi times 4. And then if I multiply 4 times pi times 4, I get a surface area of 50.3 centimeters. And now here we're back to surface area, so our units are squared. For question 7, find the radius of a sphere with the surface area of 24 pi centimeters cubed. Squared, excuse me. So this is like what we did at the beginning with volume, but now I have a different formula. They give me a surface area of 24 pi, and they want me to find my radius. So first I'm going to do what I did with the volume example, and I'm going to divide both sides by pi so that it cancels on both sides. I'm left with 24 is equal to 4r squared. So I want to get that r by itself, so I'm going to divide by 4, and I get 6r squared. Now this one we've dealt with. We've done squares and we've done square roots before. So my radius is equal to the square root of 6. Now typically we'll ask for a decimal, so if you plug that into your calculator, you should get a radius of about 2.5 centimeters. The last example is kind of like what we did with volume. I want to find the surface area of a hemisphere, but we have to change it slightly. So what you're looking for is you essentially are cutting this sphere in half, and you're finding the the surface area, of just this half of it. Now, the thing you have to remember is think of cutting a basketball in half. If I were to take a ball and cut it in half, the surface area is going to include that rounded part of the basketball, but then you also have that added base. So if you think of the cross section, it's going to be this circle right here that you have to add back on. So when you are looking at a hemisphere, you have this rounded part that you have to find the area of. That's just going to be half of a normal surface area, but then you also have to add on this base because we can't just have empty space there. We've got to cover it with that circular base. So when I do my surface area formula, the surface area for just the rounded part on top, so I'm going to write surface area of rounded part, which hopefully you understand what I mean when I say that, is going to equal to 1/2 and then times 4 pi r squared. So this 1/2 is because I'm taking just half of that normal surface area, and I can plug in my radius of 5. When you do that, you should get 157.1. And then I also have to add the area of that circle base. So the area of the circle base is going to be pi times r squared, which is 78.5. So now the total surface area of the hemisphere is going to be 157, that outside rounded part, and then plus that added on base at the bottom. So the total surface area of that hemisphere is 235.6 feet squared. So now you have homework you can be working on. So make sure that you are practicing that, and then we will be going over more of these questions later. Feel free to watch the video again, pause it as needed. Make sure that you are checking that you know how to use your calculator and that you can find the same values as I am as we're going through. Thanks for listening.